Hello, I'm Jonmichael Hands, and I'm the SNIA SSD Special Interest Group Co-Chair. I'm going to give you guys the EDSFF update for the SNIA Compute Memory and Storage Summit. So to recap, EDSFF has now changed its name from Enterprise and Data Center SSD form factor to Enterprise and Data Center Standard form factor. The big change is now EDSFF is going to allow for other device types, and the first new device type that we've seen is CXL. But there'll be more device types allowed, like, as you may know, something like OCP NIC shares the same EDSFF connector. So there's a whole family of form factors that can be in these standardized form factors. But we're going to talk about SSDs mostly today because I'm an SSD guy. E1.S is really designed for compute SSD. What does compute mean? Compute really means server. It means that these are going into mainly hyperscale servers because the hyperscalers designed E1.S to fit vertically in a 1U server. They've designed them to be modular, so there's different options for E1.S if you want to have it more M.2-like without a heatsink, or if you want to have it in a standard backplane that fits vertically in a 1U server. Obviously, it supports hot plug in different thermal environments, but it was designed to be very modular and scalable, like M.2 that was used in hyperscaler, where they just wanted to scale the number of drives when they wanted to scale the performance and quality service and isolation, but have the same performance as U.2. You can have E1.S that go all the way up to 25 watts in a much smaller form factor. The E1.L and E3.L are really these high capacity optimized form factors that have just a lot of flash on them and are designed for things like, maybe think about like high capacity QLC or high capacity TLC that's designed for storage workloads, not compute workloads. So actually storing user data where the data has to have data protection and replication and all that good stuff. So E3.S is really your mainstream form factor for enterprise servers. Again, servers have to support 1U and 2U variants, and they needed a form factor that can fit in a 1U horizontally or a 2U vertically. And also, when they were designing it, wanted to make sure when Dell and HP, and I worked with the folks that wrote the original spec, the idea was that you want to be able to have this standard version, the E3.S, which is 7.5 millimeters, be able to be smaller than U.2, so you can scale the number of I/O and scale the performance. So a lot of the modern CPUs have like 128 PCIe lanes, or if you have a two-socket server, you have a lot of PCIe lanes. So the idea was we wanted maybe some backplanes that have options to have more I/O in the front. And so one of the main benefits of E3.S was this performance scaling of just number of drives per server. Obviously, E1.S is much faster than M.2 because of the much higher power envelope. But the big benefit of the scaling in EDSFF comes from the rack unit per server, per number of drives, to be able to scale the I/O. EDSFF was designed for PCIe Gen 5, for Gen 6. It also supports CXL 2.0 and 3.0. We'll talk about today with CXL memory modules. The first we've seen is E3.S 2Ts. And EDSFF is designed to be more thermally efficient, so easy cooling, different thermal options for different server environments, and flexibility to reduce TCO. And I have some really cool use cases and examples I'm going to give to show that. As far as the specs, EDSFF comes from the SNIA SFF group, and the SNIA SFF specs are the ones that define the actual EDSFF form factors. There's 3 form factors for the actual physical dimensions. So there's E1.S, E1.L, and E3. Those specs have not been changed much recently. E1 specs haven't been touched since 2021. E3.S specifications, E3 spec 1008 was updated in 2.1 to add support of NIC sidebands 2x1C. So if you wanted to have a standard backplane with the by4 connections, but have a device that has multiple, and then clarifications around some of the stuff that they would need for maybe some CXL stuff. 1002 is the connector. So this is the actual high-speed connector that defines what's put on the backplanes, what's put on motherboards, what's put on the drives, and it's interface agnostic, so meaning that a bunch of other use cases, but beyond just EDSFF could use this, but you'll see it's mostly used in EDSFF. The additions to the 1.5 spec were really to add Gen 6 support. There's some errata, obviously, being able to have this connector be able to be used in high-speed cabling systems. So again, there's been updates there. The pin and signal spec has been updated to 4.0 to officially support PCIe Gen 6 and CXL LEDs. This is the pin list and placement for PCIe and CXL that basically just says where they all go as for when you're building one of these EDSFF SSDs, what does the pinout look like as far as PCIe signaling on the connector? The next is the SNIA SFF-TA-1034, which is the pluggable multi-purpose module. Now, this is a general purpose form factor. The first that we're going to see is potentially the ability to take something like an OCP NIC, which already leverages, the SFF-TA-1002 connector. It uses the by 16 variant of that for most of the OCP NICs, but being able to have it in a pluggable form factor that's hot pluggable like an E3. The last is the SFF-TA-1023, and this is the thermal specification. So as you can see, in a lot of the EDSFF specifications, power has now been moved to an informative specification. So meaning that it's no longer thou shalt be under this power in the EDSFF. It's really about the different thermal and airflow requirements to cool a specific power on a device type. Thank you, Supermicro, for letting me kind of steal the slide from them, but it really shows off the benefit of superior signal integrity. So when you can reduce the number of connections, and back in the day when we were looking at PCIe topologies, when you have, you had PCIe connections that could come from the PCH, they can come from the CPU, they could come from retimers, from switches with redrivers behind them, and there's all these different types of PCIe connector topologies. In PCI Express, you have a loss budget for the entire channel. And the more connections you have, the more loss you introduce. So one of the things that they utilized in one of their server designs was having the mainboard connection for the SFF-TA-1002 1C connectors basically directly to the cable, and having, they're saying, reduction in 40% of the signal loss across the topology. So this is a way to significantly improve signal integrity without a tremendous increase in costs. I know I've talked to customers, and one of the big hurdles for adoption for that Gen 6 and other higher speed protocols are basically cost. So you're going to have to be able to design these new interfaces, new speeds at the same or lower cost as generation before, and EDSFF allows you more tools in the toolkit to be able to do that. Compared to, say, for instance, a U.2 backplane, where you're having an extra hop, an extra connector on the backplane. The U.2 drive itself has a higher insertion loss than an EDSFF drive. So overall, the signal integrity of an EDSFF design is going to be much better. And overall, again, at the system level, what that should do is reduce system costs. And airflow is much improved because you don't have this big backplane that's blocking all the air with the cutouts. You can see the connectors are going right to the drive backplane, and you have free airflow that goes between the drive. So we'll talk a little bit about E1.S trends. Thank you, Storage Review, for letting me pillage some of your pictures. As we've shown in some of the previous CMSI EDSFF webcasts, last time we went around the OCP Global Summit and took videos of all these servers. Obviously Meta and Microsoft were big proponents of the E1.S and have designed E1.S across their entire fleet of OCP servers. And so you can just go to the Open Compute Contributions website to see all the different server designs, such as like Grand Canyon, even a hard drive machine has E1.S for the caching drives. So E1.S is very pervasive now in the hyperscale, and you can see now other platforms in the enterprise that are bringing maybe not OCP type designs, but bringing these standard E1.S to 1U servers. And I think, again, the E1 is designed for 1U servers. It really shows, this just the storage density in these servers cannot be matched, by U.2. You just have, it is obviously just the optimal form factor for a 1U server. You can see here in the middle, one of the new trends is that now it's not just Intel and AMD. You have NVIDIA as a major platform vendor, as AI is now the heart of the data center, and they have adopted E1.S as the form factor for these high-speed training servers. And you can see in this design, you have 4 E1.S here. And again, a lot of these AI companies are using EDSFF in training. They're using them in inferencing to have stuff local to the GPUs. They're using them in that training phase for checkpointing. So you need very high performance E1.S, but they don't want to take up a lot of space, and it's really quite literally the perfect form factor for them. So I'm very excited to see, again, not only EDSFF in traditional CPU platforms, but also now moving into the GPU and AI platforms. E3.S, again, thank you, Storage Review, for letting me steal some pictures. This is just a cool picture of one of the Dell servers. And basically, you can see here just in a standard server now, they can fit 8 drives in a 1U server, but it's not taking up the full backplane, so there's better airflow on the other side. So there's just a bunch of different options for E3 that make it really suitable for, you can see here, I'm showing the 1U and the 2U variant where you can, a standard 2U server, which just has some drives in the front of one of these storage bays. But it just shows the flexibility that, this E3 was really designed for these mainstream enterprise servers where you have a bunch of, again, a standard server might have, in the past might have just had CPUs and some DRAM and a few SSDs. Now there's GPUs, there's more NICs, there's more accelerators, there's DPUs. There's just more stuff in the server. So these 2U servers, saving that space and saving that real estate with E3 is going to be huge. And then also, obviously, you have the ability to create these storage servers with like insanely high density. I'm going to give a really cool example of how you can use some of the flexibility in E1.S for different thermal environments. So the E1.S spec for 15 millimeter and 25 millimeter go all the way up to 25 watts. Now you may want to use 25 watts if you're looking for the highest performance and you have a few drives per server, or if you're looking at PCIe Gen 6, you may certainly want to use up to 25 watts. But if you're looking at a storage-based server where you're looking at kind of TCO, well, a storage, the server I'm going to give an example of is a Supermicro server that supports 24 E1.S 15 millimeters. I'm going to show an example of running them at 25 watts versus running them at 16 watts. So if you think about the what hyperscalers have figured out, right? They have figured out that they want to run the drives at least higher, a higher temperature than standard, basically at the kind of upper limit of what the operating temp range is. They can run the fan speeds at a lower speed. Now, if you look at the fans are going to be limited by whatever the highest power components in the system are. So if the drives are running hot, then the fans will ramp up to 100%. So this is this scenario on the left here, running the drives at 25 watts. Now, if you reduce the drives to 16 watts, you obviously reduce the power from 25 but to 16 per drive times 24. That's this reduction in this light purple. But the thing that's counterintuitive is if you can reduce the fan speed from 100% down to 30%, then there's actually a very large reduction in fan power as well. So in this scenario, we're able to actually save 26% on the power on this single storage server just by reducing the SSD power, and no change. Now, 1U servers are obviously notorious for these very, very loud, high performance 40 millimeter fans. They can consume up to 30 watts. In this specific server, they have 8 of those fans. You can see here, fan 1, fan 8, and 24 SSDs. Now, again, these, so not just from a thermal perspective, but from an audible and noise perspective, it's a significant reduction. Now, if you take that and you pop it into our very friendly SNIA TCO model, I've basically drawn up like an example rack with 2 PDUs. These are 50 amp PDUs running 208 volts, and a standard PD limit for this kind of rack would be 15 kilowatts. And you could say 1 server to 16 servers, however many servers are in that rack. Now, if you're limited in that rack by power, you can actually fit 45% more servers per rack if you're estimating that if you cap the drives at 16 watts versus capping them at 25. And so that's a pretty significant reduction in TCO. If you pop these into the SNIA TCO model, we're able to see a 29% reduction in TCO. Now, obviously, if you're running a storage server, one of the most important things you can do is run higher capacity drives. So if we look at this on the right, we're moved to 15.36 terabyte drives, and that even further reduces the TCO. But you still get a very good reduction on the 15.36 terabyte drives when you're running 24 of those by running them at 16 watts versus 25. So this is just a nice example of how something as simple as a little bit of SSD power can significantly impact rack level TCO. I was very excited this year. I went to the CXL Developers Conference and I went to MemCon, and it was super cool to see all these new CXL devices. So Samsung showed off, these are a couple pictures I took on my phone. They showed off a CXL hybrid memory module that's supposed to have some SLC flash plus some DRAM and these super caps in here, and maybe a different kind of CXL use case with some NAND. They had showed off the CXL memory module with DRAM, and SK Hynix and Micron showed off the same at their booths at the CXL Developers Conference. These CXL memory modules. So this is just really cool. And what they talked about at the CXL Developers Conference quite a bit was these use cases for CXL improving memory bandwidth and memory capacity. So again, there's going to be other use cases like memory pooling and other expansion and all this stuff. But for the CXL memory modules, for the CXL 2.0 stuff that we have today, it's really about increasing the amount of memory per system and looking at workloads that need more memory, and not just memory capacity, but also memory bandwidth, because CXL can expand it. Now, what better form factor to do it in than the EDSFF E3.S2T? So these CXL memory modules, now there's now a JEDEC standard called JESD 317A is the latest version, and that's available for download on the JEDEC site, but it defines the EDSFF form factors for use in CXL memory modules. So you have an E1.S with a by 8 connector, so this is a little bit less, it's not as typical as a E1.S with the SSD when you have a by 4. They have the E3.S2T with the by 8 connection. That's again the 2C connector, and you want by 8 because you want more memory you want more PCIe bandwidth. Again, CXL uses the PCI Express electricals for the bandwidth, so the same 8 lanes will give you more bandwidth at PCIe Gen 5. And then they have defined the E3.S with a by 4 connection, so exactly the same as an SSD. And so you could make a CXL memory module that's compatible, backplane compatible with SSDs. And again, thank you Supermicro for letting me steal this picture from them. But this is just a really nice example of how you can mix and match CXL and SSDs with EDSFF form factor. You can see here in the server, they have these slots that, again, I think one of the things that people may have overlooked when the EDSFF spec was invented was that you can have a slot that is compatible, where you could have 2 slots for E3.S, or you could have 1 slot for an E3.S2T, and they can be backplane compatible. That was impossible. U.2 15mm and 7mm weren't compatible with each other, meaning you can't jam a U.2 15mm into a U.2 7mm slot and just take up the other slot. But EDSFF was designed with this backwards compatibility in mind. You can see here in the front of the server, they have this one with maybe 4 CXL memory modules and then 8 SSDs and a 1U. And so this is just a very cool config to allow you to kind of mix and match these devices. Well, it's my presentation. I get to rant a little bit. One of the things that just drives me absolutely insane is the lack of workstation and high-end desktop adoption of EDSFF so far. We need to fix this. Oh my God, nobody wants to buy a $15,000 workstation with M.2 or hard drives. Like, please, please, please. M.2 is great for boot, but not suitable for like high-end workstation workloads. Now, EDSFF, the drives themselves, like the hyperscalers, have gotten low capacity, 1 and 2 terabyte drives that are extremely suitable for boot. They're extremely suitable for any kind of like workstation workload. Quite frankly, power is not an issue. The difference between, M.2 at 8 watts versus, I mentioned, E1.S with 16 watts, when you're talking about, these systems with dual, 4090s at 450 watts each, or, 350 watt TDP CPU, the couple watts difference between for EDSFF is definitely not going to be an issue in these workstations. So again, this is and not to hate on Dell. I love Dell. I actually have the earlier version of this, the Threadripper. I have the 7865. And again, my only major gripe with this workstation, I really like the workstation, is that it's very hard to put NVMe drives in there. You can't put enterprise NVMe drives in there. Now, they could certainly delete these hard drive bays or these flex bays with the M.2 things. They have this little M.2 carrier thing, and just put EDSFF in there. That would be a perfect use case for E1.S 4 or 6 across the front of a high-end workstation that already has a lot of PCIe lanes. So please, if you make workstations, adopt EDSFF. It is really the perfect form factor for workstations. Now, Forward Insights has agreed to let me kind of present this. So thank you, Greg, at Forward Insights, for always the really informative market updates. And so you can see here, this is percent units on the left here and percent petabytes on the right here. It's really useful to look at both, because obviously sometimes the petabytes, like something like an E1.L, where the average capacity drive is much larger, this will show the adoption much better. So you can see here, as we get into, we're approaching, 2024, 2025 here. Now by units, we're already about like 15% going into next year. Now by form factor in petabytes, we add a huge chunk of E1.S already in 2024. So you can see the purple and this pinkish are E1.S, and in 2024 it's estimated to be almost 20% of the petabyte volume. And you can see out all the way out to 2028 when we actually eclipse 50% of the total volume. Now, this is what to say. To me, this is actually really disappointing, right? We started. I was designed. I was on the team that did the ruler, and we're designing the first EDSFF form factors at E1.L in 2017. At the end of 2017, the having E1.S is in production all the way from 2018, and now we're in 2024. Now, in the hyperscale, you can see it happen very fast. This shift from M.2 to E1.S, is obviously happening much faster in the hyperscale because they've just designed E1.S into all the platforms. U.2, originally we were thinking maybe U.2 wouldn't go to Gen 5, or the insertion loss or electrical costs would be prohibitive to system costs of U.2 at Gen 5. And, certainly I don't really think U.2 at Gen 5 makes very much sense when you have E3. It's just a better form factor. Unfortunately, there's all these slots out there that supported U.2, and so all the SSD vendors had to make their new drives also compatible with U.2, and you're not going to make a Gen 5 drive and not going to hobble it down to Gen 4 if the spec will allow you to go to Gen 5. So this, from a platform side, has been kind of frustrating. But from the system side, now you've seen that we have systems available from all the enterprise OEMs, from hyperscale systems that support E1.S. I don't think we'll see an issue going forward. In Gen 6, it'll be much harder transition because U.2 is just not coming along for the ride. And so the transition to Gen 6 platforms and CXL 3.0 platforms will really drive the further adoption of EDSFF. Again, just griping a little bit, I would have loved to see faster adoption. I would have liked to not see Gen 5 U.2 deployed at any enterprise OEMs or any servers. I think that just slows everything down. I realize that a bunch of SSD vendors already have U.2 drives, and so if you're a platform vendor, you're not going to make a system that just doesn't support all the drives that are already in production. So these form factor transitions are always just very, very tricky, but it is finally happening. We are seeing the volume pick up on EDSFF, and there will be a future where that's the only major form factor. So I'm actually even more bullish than this outlook here that Forward Insights has provided. So with that, in the backup, I've included some slides that I'm not qualified to talk about, but this is from the SNIA SFF committee directly on some of the updates of what's happening. Just for the folks that aren't following, I did mention the pluggable multi-purpose module that's really designed to be utilize EDSFF in this new form factor for all kind of general purpose devices in the front or the rear. There's a new internal high-speed cable modular connector system, updates to the SFP Plus and QSFP connectors, mini link by 4 by 8 shielded connector. These are the new specs, and then the revised specifications. I did talk a little bit about some of the EDSFF ones before, but this is the full list of things that the SNIA SFF committee has been up to, and they have been very busy. So with that, yes, thank you again to the SNIA SFF committee and all the hard work for the EDSFF specs for drive vendors like myself who just utilize them, and it's very, very important that we have these, and there's an industry standard for SSD and a standard form factor. With that, thank you guys. Please rate the session and let me know what else you'd like to see in the EDSFF updates. Thank you. Bye-bye.